The modern world runs on an invention so small that you cannot see it with the naked eye. Yet this tiny component has shaped history more than any other technological breakthrough. Without it, there would be no smartphones, no internet, no artificial intelligence, no space exploration, and no advanced medical devices. It is the foundation of everything digital, the heart of modern computing, and the driving force behind the world's most powerful machines. The invention that changed everything, the transistor. But how did we get here? How did this microscopic device revolutionize our world, and where is it taking us next? This is the incredible story of the transistor, the invention that built the future. Imagine a world where computers are the size of entire buildings, where sending a simple message takes days, and where technology is slow, unreliable, and incredibly expensive. This was the reality just a century ago. Before the transistor, electronics relied on large and inefficient vacuum tubes to process and amplify electrical signals. These tubes were bulky, consumed enormous amounts of power, and had a frustrating tendency to overheat and burn out. Early computers, like the ones used during World War II, required thousands of vacuum tubes and filled entire rooms. They were slow, fragile, and so power-hungry that they could only be operated for short periods before something failed. Scientists knew that if humanity was to move forward, a better solution was needed. The search for an alternative led to one of the most important discoveries in physics: the power of semiconductors. Unlike conductors, which allow electricity to flow freely, and insulators, which block the flow of electricity, semiconductors have unique properties that allow them to control the flow of electricity in precise ways. Researchers began experimenting with materials like germanium and silicon, hoping to develop a device that could replace vacuum tubes. But progress was slow, and for years, the dream of a more efficient electronic switch seemed just out of reach. Then, in 1947, history changed forever. At Bell Laboratories, a team of three scientists, John Bardeen, Walter Brattain, and William Shockley, achieved what many thought was impossible. They built the first working transistor, a small, solid-state device that could amplify and switch electrical signals far more efficiently than any vacuum tube. The world would never be the same again. This tiny invention marked the beginning of the digital revolution, setting the stage for the development of modern computers, telecommunications, and countless other innovations. At first, the transistor was a laboratory curiosity, something only scientists and engineers understood. But soon, industries began to take notice. Unlike fragile vacuum tubes, transistors were durable, required little power, and could be made incredibly small. The first commercial applications appeared in the early 1950s, with transistor-based hearing aids and radios becoming widely available. These early devices proved that transistors were not just a theoretical breakthrough, but a practical game-changer. However, it was in computing where the transistor truly proved its power. The first computers built with transistors were a massive leap forward. They were smaller, faster, and more reliable than their vacuum tube predecessors. But even these early transistorized computers were far from what we know today. Scientists and engineers still needed a way to make electronics even smaller and more efficient. The next breakthrough came in the late 1950s, with the invention of the integrated circuit, a technology that allowed multiple transistors to be packed onto a single chip. This advancement paved the way for the microprocessor, the brain of every modern computer, smartphone, and countless other devices. By the 1970s, transistors had become so small that computers could finally become personal. The rise of companies like Apple, Microsoft, and IBM was made possible by advances in transistor technology. The first personal computers brought digital technology into homes, offices, and schools, forever changing the way people worked and communicated. Then, in the 1990s and early 2000s, another revolution took place. Transistors became even smaller and more powerful, enabling the development of mobile phones, the internet, and eventually, artificial intelligence. Today, the world is more connected than ever, and at the core of this connectivity are transistors, billions of them, working silently inside every device we use. But how small have transistors really become? The answer is mind-blowing. The first transistors were large enough to be seen by the human eye. Today, modern processors contain billions of transistors, each no larger than a few nanometers, thousands of times smaller than a human hair. These microscopic components switch on and off at unimaginable speeds, processing information in fractions of a second. Every time you send a message, make a phone call, or stream a video, transistors are working tirelessly behind the scenes to make it possible. And the journey is far from over. Scientists are now pushing the limits of transistor technology, exploring new materials like graphene and carbon nanotubes that could make computers even more powerful and energy efficient. Quantum transistors, which rely on the strange laws of quantum mechanics, promise to take computing into an entirely new era. The possibilities are endless, and the future of technology is being written one transistor at a time. But what does this mean for the average person? It means that the devices we use will continue to become faster, smaller, and more powerful. It means artificial intelligence will become more advanced, self-driving cars will become a reality, and medical breakthroughs will continue to save lives. The transistor is not just an invention of the past, it is the key to the future. Without it, none of the technological advancements we rely on today would be possible. The impact of the transistor goes beyond just technology. It has shaped entire industries, economies, and societies. Silicon Valley, the global center of technological innovation, owes its name to the silicon-based transistors that power the modern world. The development of the internet, the rise of social media, and the explosion of artificial intelligence all trace their roots back to this tiny but powerful invention. It is easy to take transistors for granted because they are invisible to us. We do not see them working inside our smartphones, laptops, or even life-saving medical equipment. But without them, the world as we know it would not exist. Every major technological breakthrough of the last 70 years has been built on the foundation of transistor technology. The impact of transistors is not just limited to computers and phones. They have also completely transformed industries like healthcare, transportation, and entertainment. Take modern medicine, for example, medical imaging devices like MRI scanners, life-saving pacemakers, and even robotic surgical tools all rely on advanced transistor technology. From space exploration to self-driving cars, from medical advancements to the development of artificial intelligence, none of it would be possible without transistors. As we look ahead, one thing is certain: the transistor will continue to shape our world. The digital revolution is far from over, and new breakthroughs in transistor technology will unlock possibilities we have yet to imagine. Whether it is creating computers that think like humans, exploring distant planets, or curing diseases, the future will be powered by transistors. But what happens when we reach the physical limits of how small transistors can get? Scientists have been pushing the boundaries for decades, but we are fast approaching a point where transistors will be just a few atoms wide. At this scale, quantum mechanics starts to take over, and electrons behave unpredictably. This is where quantum computing comes in. Unlike traditional computers, which rely on binary transistors that switch between 0 and 1, quantum computers use qubits, which can exist in multiple states at once. This means they could potentially solve problems in seconds that would take classical computers thousands of years. Quantum computing is still in its early stages, but with advancements in transistors and semiconductor technology, we are getting closer to a future where computing power is no longer a limitation. So the next time you pick up your smartphone, turn on your computer, or send a message across the world, take a moment to appreciate the incredible invention that made it all possible. The transistor is not just a component, it is the foundation of modern civilization. And as technology continues to evolve, this tiny invention will remain at the heart of everything we do. If you found this story fascinating, make sure to subscribe to the channel and turn on notifications so you never miss out on the incredible stories behind the inventions that shape our world. Let us know in the comments what you think the future of transistors will look like, and stay tuned for more exciting content on the technology that defines our lives.